Alright, so this video here is a video of me making up some solutions of different volumes, different concentrations, and looking at different ways to express concentration, so that if you're ever in need of making up a solution, you might be able to go to this video and identify the section which pertains to the type of concentration you're trying to make up, and hopefully follow the process and determine what you need. Okay? Determine what you need to do. So, first example. If I want to have 0.1 liters of a 0.1 molar solution of copper sulfate. All right, so I'd like to make up 100 milliliters, which is 0.1 liters, of 0.1 molar solution of copper sulfate. All right, 0.1 molar, that means, again, molar means moles per liter, correct? Moles per liter. So that means I need to know how much 1 mole weighs, and I only want 0.1 moles per liter. That's what 0.1 molar means. All right? I can also call 0.1 molar 100 millimolar, right? I multiply it by 1,000 and put a milli in front of the molar, and so the 0.1 molar is the same as 100 millimolar. Just as 0.1 liters is the same as 100 milliliters. Okay? So, I can set up a problem here where I want to know now how many grams of copper sulfate I need to weigh out, right? So I would like to know how many grams of copper sulfate I need to weigh out. I draw my train tracks, and I start off with what I would like to have, which again is 0.1 molar, which means 0.1 moles of copper sulfate, 0.1 moles of copper sulfate for every 1 liter of solution. All right, 0.1 moles of copper sulfate for every liter of solution. And I also know that I want to have 0.1 liters. All right? Now, that'll cancel out the liters, but I'm still left with in moles of copper sulfate. And to convert moles to grams, I use the molecular weight or the formula weight in the case of copper sulfate. I have my copper sulfate bottle here. This is a hydrate, so I could use the periodic table to determine the mass of the copper sulfate pentahydrate, or I could just look on the bottle here, 249.68. And that's how many grams are in 1 mole. All right, of CuSO4 5H2O. Correct? That's my copper sulfate pentahydrate, and that's how many grams there are per mole. So I'm going to say that 1 mole of the copper sulfate pentahydrate is 249.68 grams. 249.68 grams. All right? 249.68 times 0.1 times 0.1, and that's going to be how many grams of copper sulfate I need to weigh out. And so that ends up being 2.4968 grams of copper sulfate. Correct? All right. So when I'm making a solution of 100 milliliters, it's best for me to use a volumetric flask. Volumetric flask we've talked about plenty of times, and it's going to be the most precise for me. So I'm going to go get a weigh boat here. Balance. Compare my balance. I need 2.4968. very carefully. So we have 2.493, and that'll be close enough for me. So I need to transfer this 2.493 into my volumetric flask, my 100 milliliter volumetric flask. This is, again, 0.1 liters, like I determined that I wanted, and this is the appropriate number of grams to make my solution, correct? And I would pour it in here, and then fill up the water to there, just like I did before. We've done in previous labs, okay? So that's how you make your solution in terms of molarity, all right? That's molarity. Now, this is when you're dealing with molarity. Now, if I want to have a 2% solution of copper sulfate, 2% now, okay? So 2%, try a different color. This is, all right, a 2% solution of copper sulfate, okay? Here, this made a 0.1 molar solution of copper sulfate, and over here I'm trying to make a 2% solution of copper sulfate. Now, in the case over here where we're making a molar solution, because there is 1 mole of copper sulfate in every 1 mole of copper sulfate pentahydrate, I can still work with copper sulfate pentahydrate and get the same number of moles of copper sulfate. So I can just use this value here, right? But here I want a 2% solution of copper sulfate, not a 2% solution of copper sulfate pentahydrate. So if I wanted a 2% solution of copper sulfate pentahydrate, then that would mean 2 grams of the copper sulfate pentahydrate for every 1 milliliter, or for every 100 milliliters. That's 2%. So that would be, 2% means 2 grams for every 100 milliliters of solution. All right, that's 2%, right? Because this is 2 grams in 100 milliliters of solution. If the density is close to that of water, it will be 100 grams, right? So, but again, I don't want a 2% solution of copper sulfate pentahydrate. I want a 2% solution of just the copper sulfate. So, how do I do that? Well, 2 grams of copper sulfate, what would the ratio be between 2 grams of copper sulfate and 2 grams of copper sulfate pentahydrate? So I have my copper sulfate pentahydrate. 1 unit of copper sulfate pentahydrate, 1 mole is 249.68. That's my copper sulfate pentahydrate. And what is copper sulfate by itself without pentahydrate? Well, it should be this value, 249.68 minus 18 times 5, right? Minus 18 times 5. So 18 times 5, we'll do that here on the calculator really quick. 90, so 249.68 minus 90 is 159.68. 159.68 grams for every mole of copper sulfate. All right, and that's because these 5 waters that weighed 18 grams apiece. Let's double check that with our periodic table, okay? We have copper, which is 63.55, sulfur, which is 32.06, and 4 oxygens, 16 apiece. So that's 64. before oxygen. So we have our 63.55 for the copper, 32.06 for the sulfur, and 64 for the oxygen, which is 159.61, so that's correct. All right? Okay, so this is the mass for the copper sulfate. This is the mass for the water, or the copper sulfate with the 5 waters, pentahydrate. So if I take the mass of the copper sulfate pentahydrate, and I take the mass of the copper sulfate without the pentahydrate, right, which is the 90 because of the 5 waters, the ratio between, if I wanted 2 grams, it weighed this much. So if it weighs this much, how many grams do I want to have? All right? So if I solve this here, I can do cross multiplication, and I should get 3.12 or 3.13 grams of copper sulfate pentahydrate. All right? So if I want to make a 2% solution that contains 2% copper sulfate, and I'm using a pentahydrate, I actually need to weigh out 3.13 grams of the copper sulfate pentahydrate. All right? So that's my molarity, that's my percent solution, okay? Now, the same thing can be done for parts per million, all right? If I want to do a parts per million, do that over here. Okay, again, a part per million solution. Why do we call it a part per million solution? It's called a part per million because what it refers to is parts of solute, what's being dissolved in the solution, to a million parts of solvent. Okay? Now, solution, a million parts of solution. Now, how do we get a million parts of solution? Well, if we had, for example, 1 liter of solution, 1 liter of an aqueous solution, if we assume the density of that aqueous solution is 1 gram per milliliter, so if it doesn't necessarily need to be, but for this scenario we can assume that 1 gram for every milliliter, that's the density of the solution. So if we have 1 liter and it's 1 gram per milliliter, then 1 liter is also 1,000 milliliters, and 1,000 milliliters is also 1,000 grams, because 1 gram is equal to 1 milliliter. Therefore, in milligrams, 1 liter is 1 million milligrams. So 1 liter is 1 million milligrams. So if I have 1 milligram of copper sulfate in 1 liter of solution, this would be 1 part per million copper sulfate. All right? So I want to weigh out 1 milligram of copper sulfate to put it into 1 liter of solution. If I just wanted 100 milliliters or 0.1 liters, then I would need 0.1 milligrams for every 100 milliliters. So, again, if I'm making a 1 part per million solution of copper sulfate, and I need 1 milligram of copper sulfate. If I need 1 milligram of copper sulfate, I need to use this same ratio here to determine exactly how much copper sulfate pentahydrate I need to weigh out to get just the copper sulfate. So again, 249.68 grams for every mole of the pentahydrate. And this is how much we would like to know how much we have to weigh out if we want 1 milligram, 159.68 grams per mole. So if it weighed 159.68 grams per mole, we would weigh out 1 milligram and add it to our liter. But because it weighs 249.68, because the extra water, then we need to multiply that value, or solve for x here, which will be 3.13 divided by 2. 1.56 milligrams. All right, so this is parts per million, right? And this is why we call it parts per million. So if you ever forget, you should either do this exercise yourself or come back here to remember how to do the exercise yourself. But you should start remembering what parts per million refers to. And also, again, if you're dealing with a pentahydrate, you need to make sure that you use this ratio to determine exactly how much solution you should add. All right, that's it. So we talked about different ways to make solutions, different methods for specifying concentrations. We talked about molarity, percent weight volume, and then parts per million. Another way to make solutions is percent solution, volume to volume, right? So, and this is usually used when we're mixing solutions that are two solvents. For example, water and ethanol, or water and methanol. Now, methanol and ethanol, which are two fine sample examples that we could use, are colorless, so you can't see the color. So I'm going to work with a solution here, which is copper sulfate, and I'm going to pretend like this is 100% ethanol or something like that. Okay? So it's nice and blue for us, so we can see the color. So here's my 100% ethanol, and I'm going to transfer some of this 100% ethanol into one of these bottles. All right, so right now it's set to 1 milliliter. All right, so I can transfer 1 milliliter. I'll do 2 milliliters there so we can see it, right? Okay, so now I have 2 milliliters. Maybe if I put over here on this white surface, we'll be able to see a little bit. So I have 2 milliliters of copper sulfate solution. All right, this is the same copper sulfate solution that we made earlier, so it's actually 0.1 molar, right? But for us, we'll call that 100% copper sulfate solution. All right, as if it's 100% ethanol or something like that. All right, now if I would like to make a 50%, let's make a 50% first, right? If I want to make a 50% solution of the copper sulfate here, then I can take 1 volume of my 100%. I can change tips as necessary. And take 1 volume of my 0%, which is just the water, right? And then I can also mix it if I need to with this, or I can just shake it. So there's a 50% solution. And you can see the difference, right? So that's why we're working with copper sulfate, just so we can see the difference. So I made 100% here, I made a 50% here. I can put a little bit of water into one of these bottles just to show you what a 0% looks like, right? And then I can make a 25% as well. Now let's say I just want to make 1 milliliter of a 25%, okay? So if I want 1 milliliter of 25%, this is 1 milliliter, right? I would move this down to 750 microliters, right? Which is 0.75 milliliters. And now I add 0.75 milliliters of water to one of my vials. All right, now I have 0.75 milliliters of water in there, but I wanted it to be 25% copper solution. So now I change the 0.75% or 0.75 milliliters down to 0.25 milliliters. 0.25 or 250 microliters, and that's going to be of the 100% copper sulfate. All right, now we see it's not completely colorless, it's not as bright as the 50%, it's somewhere in between. So we have a 25% solution. If I wanted to make a 20% instead of 250, I would go down to 0.2, and then I would have to use 0.8 of water. Right? So that's fairly straightforward. So here I have a 100% solution, a 50%, a 25%, and a 0% solution. And I don't have to make very large volumes always. I can use a micro pipette here to make my solutions like that.